This section's on plant water requirements. And the first thing we need to be aware of are things that are involved with not only the plants but the atmosphere around it. So we'll start with evaporation. And evaporation will occur due to mainly solar radiation and also due to temperature and also due to wind. Right, the three major keys to effective evaporation. Now, interestingly enough, evaporation is a surface condition phenomenon. We only lose evaporative water from the surface of the plant or from the surface of the soil. So if we have water on the leaves of plants, then that would be evaporation. Not the water that comes up through the plants and is emitted from the plant. That's not part of transpiration. It's just water that had beaded on the leaves of plants or got caught in cups where the leaves might intersect the stems and so on. That water, as it is evaporated, is considered true evaporation. Then the other evaporation will come off the soil surface. Now there will be some internal soil evaporation that works its way up through the pore spaces that are already voided. And so we'll get some water vapor coming up out of the soil, which is also true evaporation. Evaporation is magnified, number one, when we keep the ground constantly wet. If we allow that ground surface to dry off, then our evaporation rates are going to drop as the ground surface gets drier, because it takes a free water surface for evaporation to occur. You know, the easiest place for evaporation to occur is off the pond or off the stream or off of a lake or any body of water that's just freestanding out there in the sunlight and solar radiation and all of that wind and everything hitting it. That's where we get a large amount of evaporation. In fact, we talked about the evaporation pan and the fact that it will always lose a certain, not always, but it will lose a certain percentage of water most days. And all we're doing is measuring what is evaporating just right off the surface of a free water body. The soil isn't that way. It's not solid water. So our evaporation rates aren't as high off of the soil surface. Our evaporation rates aren't that high off of leaf surfaces unless it's just totally beaded with water. But it is part of the player out there in the field. The more ground cover we get, the less evaporation we're going to have. You know, the more shading that we do to the ground surface, the less surface evaporation of water coming off of that position. Obviously, if you have a square foot of soil that is totally exposed to the sun versus a square foot of soil that is shaded, the part that's in the sun is going to lose considerably more water than the part that's in the shade. So different crops are going to have an effect. If we have a field of corn, once it covers over with the leaf surfaces, which doesn't take too long into the growth rate of corn, the rest of the season we have a total canopy, and we have reduced our surface evaporation quite considerably due to the fact that the sun never gets down to the ground surface, versus a field of onions. In onions, we just got a few little stems sticking up in the ground, and virtually the whole surface is exposed to solar radiation and therefore more evaporation off of that surface. So to give you an idea of a couple of crops and the difference, take a look at turf. We can take a look at a home lawn that might be cut at 2.5 inches. A lot of shade on that soil. So, I mean, sunlight does not hit the soil in a turf that's cut 2.5 inches and is growing. But compare that to a green, a putting green, that we're cutting at, what, 1/8 of an inch, or maybe slightly over, slightly under 1/8 of an inch. Now we actually have exposed surface of some of the soil. So our evaporation rate goes up on that particular crop. So it takes more water to water close-cut turf than it does taller-cut turf, simply because of the change in the amount of evaporation that's occurring in that system.